Okay, everybody, this is your first test coming up tomorrow. This is the academic chemistry math test review, so I'm going to go through this stuff with you, make it as quick as I can, but as thorough as I can also. Please, please, please take time for this review. Okay, matching. Match the following quantities to the appropriate SI unit, metric unit. So, liter is simply a unit of volume. Meter is a unit of length. Gram is a unit of mass. Kelvin is a unit of temperature. And kilogram is a unit of mass also, because, here's how you write it out: kilo and gram. And if you said mass, grams is a unit of mass, then kilogram is a unit of mass. Okay. Which type of property, number 6, would be used to identify an unknown substance? Those are intensive properties. Intensive properties that do not depend on the amount of a substance. Number 7, which statement is true about intensive properties? Well, they don't depend on the amount of a substance present, and they do not include properties like mass and volume, because mass and volume are extensive properties. These are extensive, okay? And they change when the size of the sample changes. That's not true either. The only thing that is true is that they include properties like color and density. Oops, I don't want to cross it out, I want to erase it. So that's important, because color is an intensive property that no matter what, if you cut a piece of paper 1,000,000 times and the color of the paper is red, then every bit of that paper is going to be red. And density, that doesn't change with the amount of matter you have either. All right, which of following is not an extensive property? So we're asking, what are intensive properties for this one? Okay, what are intensive properties for this one? Well, boiling point is an intensive property, so this is not an extensive property. Density is not an extensive property, and color is not an extensive property. Those three are all intensive. Volume is an extensive property. Okay, so the answers to this is not volume, it's all these three. Okay. Number 9, where does a decimal always go in scientific notation? Not before the 2 digits. There is no decimal. That's not true. Before the first non-zero digit. That's not true. It's after the first non-zero digit. So this is the answer. So let's take a look. If we have the number 108, okay, then the decimal would go after the first non-zero digit, and there will go. Oops, right there. At 1 is the first non-zero digit. Okay. Expressing the following in proper scientific notation. We have 108,000 here. So remember, the decimal goes in between the first 2 digits or after the first non-zero digit, so it goes there. And we're going to move that decimal to the right to find out how many spaces we moved it. Oops, that thing's coming up. 1, 2, 3, 4, 5. It's a number greater than 1. And so the answer happens to be 1.08 times 10 to the 5th. Okay? And moving along, number 11. We have a number in scientific notation. We want that number in an expanded form. We want it to get to be a normal number. So we have 4.65 times 10 to the 6th. And so I'm going to take that and rewrite it, 4.65. And that means we got to move that decimal 6 spots to the right. So 1, 2, 3, 4, 5, 6. Fill in the rest of the gaps with zeros. And we have an answer, 4,650,000. This is the answer right here. When you are setting up a dimensional analysis problem, always start with what? You always start with the answer? No, you do not. You're trying to solve for the answer. The number only in no units? No. You always start with what is given. And where that number goes when you're doing dimensional analysis is always in this area right here. Okay, that's where it goes. Number 13, the last step in solving a dimensional analysis problem is to multiply the numbers across the top and divide by the numbers on the bottom. That is absolutely true. That is the last thing that you do. That is true. All right, Number 14, convert 2.76 centimeters to inches. Okay, that's easy. So we're going to draw railroad tracks like this. And I'm going to put 2.76 centimeters. We'll always put units there. And since we want inches, right? So we're going to put inches way down here. Well, here's the conversion factor we're going to use. If we have centimeters in the upper left, we have to have centimeters down here, which means inches is going to go up here. How many centimeters? 2.54. And then we have 1 inch on top. Those units will cross out. We're left with inches on the top. This is a division problem because you have 2.76 in the numerator and we have 2.54 in the denominator. And the answer happens to be, when you calculate it out, 1.09 inches. Okay, let's go to the last page. Number 15, converting 1.2 gallons to milliliters. So we write our given 1.2 gallons. We're solving for milliliters. We want milliliters over here. And we have 2 conversions we're going to use, okay? So we have gallons up here. We need to use this conversion here. So 1 gallon will go down here, and 3.79 liters will go on top. If liters is on the top right here, then go ahead and put liters down here because we're solving for milliliters up here. And so we have 1,000 milliliters on the top, and we have 1 liter on the bottom. We multiply everything across the top, and we get 4,548 milliliters. Okay? 16. We said quantitative data today had to do with numbers. Quantitative data and quantitative properties have to do with numbers. Quantity. Okay? And so that's numbers. All right. So the question is, which of the following is a form of quantitative data? Well, you're looking for the only answer that has numbers in it. Well, that happens to be D. All of the rest are descriptions, and those are qualitative data. So when we go down to 17, which of the following observations is qualitative, we're looking for descriptions. Boy, if I can spell today. Descriptions, a quality. Okay, that's what it means, descriptions. So A has numbers in it. The pH of the solution is 12. No, that's quantitative. B, the crystal weighs 2.6 grams. No, that's got numbers in it. D, you see 31.9 milliliters. No, the only one that can be a quality or qualitative data is C. The solution turned green with mixed with an indicator. That's a description, green. Number 18. Which of the following is an example of a quantitative property? Again, we're talking about numbers. Whether it's data or a property, it doesn't matter. We're talking about numbers. Which one is the only one with numbers? That happens to be B. The density of the substance is 3.6 grams per cubic centimeter. Number 19. What would you do if you spill a chemical on your skin? Wipe it off with a cloth? No. Ignore it if it doesn't hurt? No. Cover it with a bandage? No. You wash it off immediately, plenty of water, and then, obviously, you tell me. Number 20. What is the first thing you should do if a fire breaks out in the lab? Some of you would probably say use the nearest fire extinguisher. That is a good answer, but it's not the totally correct answer. Run out of the building? No. Maybe later. Yeah, we'll do that. Try to put out the fire with water? No, you don't want to do that because some things don't require water to put them out. They react violently with water. The thing that you do is you alert me first, okay? And then I will tell you exactly what to do, okay? That is your review for this test tomorrow. Please look it over, and good luck.